Hi students, it's Ms. Oberly here with lesson 1-7. I should make sure my volume is turned up. Today by the end of this lesson you will be able to write 2-column proofs about segment relationships. There is just one postulate you need to add today to your postulates, theorems, and axioms sheet, and it is about segment addition. And this, I know, is something that you already probably understand, but we need to know the reason that we're going to give when we write some proofs. So if these 3 points are collinear, then point B is between A and C, if and only if AB plus BC equals AC. So this idea is something you'll be writing out a lot. The whole segment equals the sum of its parts. So keep that in mind. Once you're ready to go with that, let's do our very first and only example for today. I would copy down the 2 columns first. So give yourself 2 columns. On the left side, we will always write our statements. On the right side, we will give a reason for each statement. And today we're starting with the given JL equals KM. So JL equals KM. And we are trying to prove that JK is equal to LM. And it looks like it's true, but today we are going to give some reasons as to why that is really true. So, of course, we start with what is given to us. JL equals KM. And that is true because it is given. And I always like to fill in what we're trying to prove. Next, we know that that's where we're going to end. And it's a little easier to see in a 2-column proof than a paragraph proof. But if you're writing a paragraph proof, that would always be your last sentence. And JL, this segment here, JL equals JK plus KL. And do you remember why that's true? The whole segment is the sum of its parts by the segment addition postulate. And KM equals the sum of its parts. So KM equals KL plus LM for the same reason. So therefore we can say that since JL equals KM, that was given to us, then let's switch colors, JK plus KL, so that's what this was, is equal to KL plus LM. And that's true because of good old substitution. Now we're close to getting what we want to get alone. Remember, we want JK to equal LM. But what do we have on both sides of the equal sign that we need to get rid of? We have a KL. And if we have the same thing on both sides of the equal sign, we can just subtract them from both sides and they will cancel out. So JK is equal to LM by the subtraction property of equality. And that is not how you spell subtraction. Let me try that again. Where's my eraser? I guess I could rewrite this. The subtraction property of equality. I can't write and talk at the same time. You make your proof final by giving a little symbol, and then you are good to go.